Welcome back to the deep dive. So you're here because you want a critical look at agriculture's environmental cost. Today, we're really digging into land use, specifically comparing traditional farming, often seen as the bad guy, against more modern methods.
That's right. We're looking closely at a fascinating study out of Western Ethiopia. It compares traditional shifting cultivation, you might know it as swidden or slash and burn, with fields converted to modern monocropping.
And we're not just talking yields, we're focusing on the soil itself, specifically soil organic carbon, SOC, and soil total nitrogen, STN.
Exactly. These are, fundamental for soil health, and they play a huge role in the climate system, too.
Okay, before we get into the data, maybe quickly define shifting cultivation.
Sure, it's a big deal. Globally, it covers about 280 million hectares, supports maybe 500 million people. The cycle is basically clear some land, often by burning, farm it for just a year or two, say, maize or sorghum. And then the crucial part, let it rest, go fallow for a good while. In this study, it was typically 8 to 10 years.
Right, and that's where the controversy comes in, isn't it? It gets a really bad rap. Globally, people blame it for deforestation, greenhouse gas emissions. Some reports say up to 60%.
Precisely. The dominant narrative, especially in policy circles, is that swidden is just inherently destructive, bad for carbon, bad for the land. But interestingly, other research suggests, well, maybe not. Maybe if the fallow periods are long enough, it can actually work, sustain things. So our job today is to see what the data from this specific Ethiopian site tells us. Does it back up the global view or challenge it?
Okay, let's set the scene. Where exactly did this study happen?
Budea Bila district, Western Ethiopia. It's known for pretty rough, hilly terrain. And the soil type there is important too, vertisols. These are dark, clay-heavy soils, quite deep.
Got it. And what were they comparing exactly?
They looked at 5 different land use types, and this is key. They sampled soil way down a full meter deep, 100 centimeters.
A whole meter. Wow. So they weren't just skimming the surface. They wanted the full picture of carbon and nitrogen storage.
Absolutely. So first, the gold standard. Natural forest, NF. This patch hadn't really been touched for over 300 years, apart from some traditional honey gathering. That's our baseline.
300 years. Okay, that's a seriously stable ecosystem. Sits a high bar.
It does. Then they looked at shifting cultivation areas, specifically plots that had been fallow for 3, 5, and 7 years, SC3Y, SC7Y. These represent the system in its different recovery stages, but still within that traditional cycle.
Okay.
And finally, the monocropping field, MCF. This land used to be under shifting cultivation, but was converted about 10 years ago, usually because of, government advice or market changes.
Right. And the initial hypothesis, kind of following that global narrative you mentioned, was that both shifting cultivation and the new monocropping would show lower carbon and nitrogen compared to that old forest, right?
That was the expectation, yes,
Yeah.
which makes the actual findings really stand out.
Okay, let's hear it. What was the first big surprise?
Well, this is where things get interesting. They found no significant difference in the total SOC and STN stocks down to that full meter depth between the natural forest and any of the shifting cultivation sites.
Wait, hang on. No difference.
Hmm.
Between the 300-year-old forest and the areas being burned and farmed, albeit with long rests.
None that was statistically significant across the whole soil profile. The traditional system in this context was essentially holding on to its carbon and nitrogen just as well as the undisturbed forests.
That's huge. I mean, it flies in the face of so much policy and common understanding about slash and burn. So, is the global thinking just wrong, or is there something special about how these farmers manage it?
The data points towards the latter. It seems this specific traditional system is incredibly resilient because of how it's practiced. The researchers suggested 3 key reasons, all tied to the traditional methods.
Okay, what's reason 1?
Fire management. Because they only burn every 8 to 10 years, you don't get massive amounts of fuel building up. So the fires tend to be, let's say, lower intensity, not these raging infernos.
Ah, so it's not hot enough to really bake the carbon deep in the soil.
Exactly. Soil organic carbon really starts to combust, to burn off, around 200–250 degrees Celsius. These managed burns likely stay below that threshold. They clear surface stuff, release some nutrients, but they don't cook the deep soil carbon reserves.
Okay, that's clever. Almost like a cool burn. What's the second mechanism?
This one might be the most critical: tillage, or rather, the lack of it. When the local farmers plant maize or sorghum, they don't plow the field. They use a traditional wooden stick. It's called a bihorda.
A stick?
Yeah, just to poke a small hole in the ground, drop the seed in, cover it up, that's it.
So zero tillage. Minimal disturbance, completely different from turning over the whole topsoil.
Fundamentally different. When you plow, you churn the soil, expose all that organic matter to air, and decomposition just skyrockets. By barely disturbing the soil, they keep the carbon and nitrogen locked safely away.
Right. And the third factor, the fallow period.
The long rest. That 8 to 10 years seems absolutely vital. It gives the soil ecosystem time to fully recover, replenish nutrients, rebuild structure.
Makes sense.
And it wasn't just carbon and nitrogen. Other things stayed stable too. Soil pH, texture, density, laggarage. They weren't significantly different between the shifting cultivation sites and the natural forests. It points to a really well-balanced, sustainable cycle, at least here.
Okay, so the traditional system, managed this way, looks surprisingly healthy for the soil. But then the pressure comes. Policy changes, population grows, markets develop, and farmers are pushed to convert.
And that's where the story takes a sharp turn. The shift to continuous monocropping fields, the MCF, that's where we see the damage, really dramatic damage. The soil health just plummeted. Remember, these fields had only been monocropped for 10 years, but their carbon and nitrogen levels were significantly lower than all the shifting cultivation sites and obviously the forests.
Significantly lower. Can we put some numbers on that? How bad was the loss in just a decade?
It's pretty shocking. Over those 10 years, the soil organic carbon stock dropped by 45 to 50%.
Wow. Half the carbon, gone.
Roughly half, yeah. They estimated the annual loss at about 11.6 megagrams of carbon per hectare per year.
11.6. That sounds like an incredibly fast rate of depletion. That's not sustainable at all.
Not even close. You're essentially mining the soil's foundation. And nitrogen followed suit. Soil, total nitrogen stocks fell by 18 to 45% over the same decade. That's an estimated loss of about 0.6 megagrams of nitrogen per hectare per year.
Okay, so what were they doing differently in these monocrop fields that caused such a catastrophe in only 10 years?
They basically flipped the traditional practices on their head. The big one was tillage. Intense, repeated tillage. Instead of the bihorda stick, they were using oxen pulling a traditional plow, the maretia, and they weren't just doing it once, they plowed 3 or 4 times before planting crops like teff, maize, or sorghum.
Right, that repeated physical disruption, churning the soil over and over.
Exactly. That massively speeds up the breakdown of organic matter. Plus, 2 other things were happening. One, no more fallow period meant no more input of organic stuff from returning vegetation, the leaves, the roots that rebuild the soil.
Hmm.
And 2, with less plant cover and all that plowing, the soil was much more vulnerable to erosion. Wind and water just carrying away the topsoil, carbon, nitrogen, and all.
They were using fertilizers, though, right?
Yeah.
Urea, DAP.
Oh.
Didn't that help replace the nitrogen?
Well, it didn't stop the overall stock of nitrogen and carbon from collapsing, and it added another problem. The use of those specific inorganic fertilizers actually made the soil more acidic. The pH dropped in the monocropped fields compared to the shifting cultivation areas.
So lower fertility and more acidity. Not a good combination.
Definitely not. It further degrades the soil quality, makes remaining nutrients less available to plants.
Okay, stepping back then. This isn't just a local soil issue. What are the bigger implications?
Well, globally, it's pretty clear. When you lose that much soil, carbon, and nitrogen, you increase greenhouse gas emissions CO2 from the carbon, N2O, nitrous oxide from the nitrogen. It directly fuels climate change.
Right.
And locally, the consequences are immediate. Losing nitrogen, increasing acidity, that equals lower soil fertility, which down the line likely means lower crop yields, hitting food security, making the whole farming system potentially unviable long term.
So the big takeaway here seems to be, in this part of Ethiopia at least, the traditional shifting cultivation, with its long fallows and minimal soil poking, was actually doing a decent job preserving the soil.
Yeah.
The real problem, the environmental disaster, was the switch to the intensive, high-tillage monocropping.
That's what this data strongly suggests, yes. It really forces us to reevaluate the blanket condemnation of shifting cultivation. Maybe the focus shouldn't be on stopping Swidden itself, but on understanding why it's being replaced and finding ways to avoid this kind of high-impact conventional conversion that just destroys the soil so quickly.
It really highlights how sophisticated that traditional knowledge is, doesn't it? The way they farmed, minimal disturbance, long recovery, mattered more than the fact they were clearing forest patches periodically.
Absolutely. It shows a low-tech, long-cycle system can maintain soil health where a supposedly more modern, intensive system fails quite spectacularly. And here's something really interesting to think about for you listening. The plowing method they used in those failing monocropped fields, the oxen-drawn Maresha, it's still pretty traditional, right? Not super high-tech mechanization. If that relatively simple intensified tillage caused a 50% carbon loss in just 10 years, what might happen with even more intensive, modern, maybe tractor-based conventional farming in these kinds of fragile tropical environments? What does this rapid soil degradation mean for future food security in places under pressure to abandon systems like Sweden, systems that, as we've seen here, might actually be quite stable?